typical linear and quadratics, and also talking about the end behavior. Alright, so let's get busy with some of these problems. Okay, so here you have terms and definitions. I'm going to let you guys pause the video right here and go ahead and copy some of these down. Ignore the little f of x right there. I'm not sure why that's on the screen, but the word is exponent. But you have standard form, degree of a polynomial, leading coefficients, polynomial functions, and power functions as a little subset. So if you want to copy those down real quick, you can. Pause the video and I'm going to move on. So what I'd like to start with here is these three questions. And the bottom line is if we don't have a polynomial, then we're not going to answer the question of degree or leading coefficient. And that's the case in this first one. This is not a polynomial because of the a squared. Really, that is a to the negative 2 if you raise it up to the top. So therefore, this is not a polynomial. And so we would move on. The second one, the leading degree in this case, because everything's pretty legitimate, will be the 5th degree. So if you say, not the leading degree, but the actual degree will be a 5th degree and the leading coefficient, you're going to look at the number in front of that degree, and it's a 1. So I don't mind if you abbreviate LC, and that's going to be a 1, or if you want to actually write it out. But it needs to be identifiable. Now this last one, everything's good for a polynomial, and you can see that the 6th degree is the one that's going to win. So it's a 6th degree, and the leading coefficient, you should have guessed by now, is a 2. Just because 11's higher does not mean that it's the leading coefficient. It's really 2 because it's with the degree. Alright, we'll talk about any question you may have in class. So here we have a quick example of just evaluating the function. In this problem, you see that Roscoe, he is drawing n dots on a piece of paper, making sure that no line contains 3 of the dots. The number of triangles that can be made using the dots as vertices is equal to this equation. And kind of just an idea for what he's doing. Here's a dot, here's a dot, here's a dot, here's a dot. He is just trying to draw triangles and see how many triangles he can get in a sense. So, and we keep adding the dots, and the actual number of triangles adds up as well. So as we take these questions, what is the degree of f? So hopefully you already know that. This will be a 3rd degree polynomial. So this is a 3rd degree. And if Roscoe drew 15 dots, it says earlier that n is the number of dots. So we're just going to plug the number 15 in for n. So I'm going to have a 1/6 times, and it will be 15 to the 3rd power minus 3 times 15 squared plus 2 times 15. And all that's in parentheses because I'm going to multiply it by 1/6 in the end. What I'm going to let you guys do is crunch that out, but make sure that you don't do 3 times 15 first. Make sure you do 15 squared first, and then you do 3 times that. And 15 cubed, and 2 times 15, and then divide it all by 6 or multiply it all by 1/6. Alright, good luck. We'll see if you get it right. Now in this particular problem, they're asking us to also do a function value, but this time we're plugging in variables. So we're going to do the f function for 3c minus 4 and also for just a c when we really have an x in the function. So we're going to use this function right here. But we're going to plug these items in, 3c minus 4 and c. So as we go, I'm going to be doing f of x. So I will say Instead, 3c minus 4 squared plus 2 times 3c minus 4. And then minus, I'm on the second part now, I'll put it in green. So that's going to be in green. Minus 5 times, I'm just going to change the variable from x to c now. So it's going to be a c squared plus, sorry about that, plus 2c and minus 3. Alright, so let's see how well we can do this. I'll put this in black now. That's going to be 9c squared minus 24c plus 16. That's a little shortcut doing this piece right here. And then it will be plus, what is that, a 6c and minus 8. And now I'm going to distribute my negative 5. So minus 5 c squared, and that's a minus 10c. And that will be a plus 15. Alright, so I'm going to highlight some like terms here. C squared, right there, so that's going to be a 4c squared. And then let's highlight our c's. So negative 24c plus 6c minus 10c. So let's see if we can add that up accurately. Negative 24 plus 6 is negative 18, and negative 18 minus 10 is negative 28c. So let's put that down. Bingo. Alright, and then the last one, let's pick blue, and we've got a number of 16, negative 8, and 15. So 16 minus 8 is 8, and 8 plus 15 is 23. Now I could have made a mistake. I'm trying to do this in a hurry, so let's see. If you want to stop this and make sure I did it right, but the bottom line is we're doing function values of variables in this one, so our answer is still going to be an expression in terms of c. Alright, next problem. So this problem is for you to try based on the last one, so you can flip back to the last one and check it out. But I did have the answer put on the next slide, so I'm warning you that now in case you want to not flip so quickly to the next one. So the answer is about to come up. 3, 2, 1. There's your answer. Alright, check yourself. Okay everybody, what we have here is just a layout of the first 6 degrees, going from degree of 0 to degree of 5. So we go 0, 1, 2, 3, 4, 5. It's important for you guys to kind of have an idea what these look like. The degree of 0 is a constant flat function. Degree of 1, remember, kind of like mx plus b. For degree 2, think of x squared. That's a negative x squared showing up. And then x cubed. And then we haven't talked about a lot of these, but x to the 4th and x to the 5th. That's what these degrees mean. Now, there's some other details that go along with this. We'll talk more about it in class. But if you notice, the first degree has 0 humps in it. And the second degree has 1 hump, 1 change of direction. Degree 3 has 2. You see those. And degree 4 has 1, 2, and 3. And the 5 has 1, 2, 3, 4. So it's always one less curve or one less hump according to its degree. Take note of that. It can have up to those many curves, but it doesn't have to have them. Just we'll talk about that. So real quick on end behavior, this is where we're getting to the last part of this section. So the domain of any polynomial function is always going to be all real numbers. Alright, make sure that you understand that and write that down. Now the range, on the other hand, I cannot promise you. It is going to depend on the direction of the endpoints of each graph. And we'll talk about that in the next slide. Jot this down. Okay, now bear with me on this slide. I want you to first think about this, that f of x is the same thing as y. Alright, if you buy into that, you're going to be in better shape. So when you see f of x, think of the y values. So as we go through here, I want you to look at the even degrees first. So in the even degree, if the leading coefficient is positive, you guys remember that it opens up. If it's negative, it opens down. So that's anything from a squared to a fourth to a sixth, eighth, and even degree. So the end behavior, everybody, is described as this. F of x goes to positive infinity, goes up, as x goes to negative infinity. So as the x goes this way, what is the blue graph doing according to my marker? It's going up. So I like to say it in reverse. As x goes this way, f of x goes up. As x goes positively to the right, positive infinity, the f of x, the y value, goes up. Now conversely, the other end, as x goes to the left, or negative infinity, further out, further out, further out, the y value gets negative. Alright, so it goes to negative infinity. So that's what you're going to be reading here. And I'll clarify this in class, but I would have this down. It's also in your book. And also notice the domain for both of these. The domain is all real numbers. And the range is everything above the minimum for the top one, and it's everything below the maximum for the bottom one. Look over here at the odd degree ones, though. Think of straight lines and slope. Alright? So if you have an odd degree and it's positive, the left side of the picture is going to be going down and the right side is going to be going up. So it's got a positive slope to it if you laid your pencil down. Just the opposite. If it were negative x to the fifth or x cubed or whatever, then it's going to be going down because it's a negative slope. So it starts high and ends low. If it's positive, it starts low and ends high. So we'll use the same kind of notation with the positive and negative infinities as we did over here with the even ones. I think we're going to have to talk more about what that means in class, but write this down and look at your domain and range as well for the odd degrees. It's always all real numbers, so that's a pretty easy thing to remember. And lastly, we're going to talk about solutions, or zeros, if you remember, we can call it that, of even and odd degrees. Let's say we had like a parabola. You know, you have one of those here, and it's doing this number. It has two different roots, right there, right there. So that's 2. So in even degree polynomials, they have an even amount of roots. They can have 0, 2, 4, and it depends on the degree. This would have to be a second degree polynomial. This would have to be a fourth degree. This would have to be, well, according to how many curves it has, you would add 1 to its degree, but it never crosses, so it doesn't mean it's a 0 degree, it just means it never had an answer. So this second degree polynomial, remember, it can have 0 roots like that. It's never crossing the axis. So make sure you're aware of that. Odd degrees, though, they will always cross, because if you think about it, I told you that they have to go up and down. So if it's a positive one, it's doing this. If it's a straight line, it's going to touch at least one time right there. So just keep in mind that an odd degree has to have a 1 answer, 3 answers, 5, or so on. And we'll talk about different situations in class. But jot these two basic examples down and maybe the definition up top. Alright? So lastly, folks, make sure you flip and don't flop. And of course, rewatch some of these things if you got confused on it. And here's the homework, or the classwork really. This is what we'll be doing in class. You may have already started it. That's okay. So it's 14 through 34, even 35 through 40, 74, and 84 are review questions. Make sure you write down the problems and jot down any sketches you might need to. All right? I look forward to talking to you guys in class. Have a good one. Bye.